I'm doing it. Okay, guys. Several people asked about notes for this section, and we haven't been giving notes. And I was kind of curious to see if people would take notes of their own, and many of you guys have. But if you want the official version, away we go. So here's the splash screen. Of course, pause if you need to, if you want to get all this down, because we're just going to jump right into it. So you know what's coming first. You know that you're going to have the essential terms associated with trigonometry first. So let's get to it. The first term, ratio. So let's talk ratio. It's nothing more than a comparison of two objects. In this case, we're going to have two values or two numbers, two measurements is really what we're going for. So we put that in parentheses. Now, specifically for this section, we talk measurements. We're probably going to talk two parts of a triangle. But in the end, ratio, we're just comparing two things that make sense to go together. Similarity, and let's talk about the geometric sense of similarity. It's definitely going to be, and you're going to hear the announcements, but I'm going to keep going, so just fair warning. So maybe that's pretty loud. Anyway, similarity just refers to a relationship of proportionality. Okay. Okay, so what I mean by relationship of proportionality means that, of course, the sides are relatable by a common ratio. So proportionality is tied to the term ratio. Okay. So relationship of proportionality refers to some kind of ratio. You've heard these terms already, opposite, adjacent, hypotenuse. Let me draw you a picture because it makes the most sense. So if I pick like a reference angle, okay, the term opposite, adjacent, hypotenuse just refer to the sides of a triangle in relationship to that reference angle. So the opposite side is here, the adjacent side is the one that touches it, and the hypotenuse will always be across from the right angle. So again, they're just terms that kind of refer to parts of a triangle. When you pick a reference angle, and you have to pick the reference angle before any of those make sense. Have to pick this first. Have to pick first. Which is why, by the way, that's always the first step of solving a triangle, because if you don't pick this reference angle first, then you know what the pieces actually mean. We use the term solve quite a bit in this section, and solve simply means to find the value of any part of the triangle you don't have already. Yeah, support those ladies partners. Okay, so that's solved. Let's talk about inverse function. So inverse function, this is interesting because the definition is going to be simple, but the explanation is going to be a little more complicated. So an inverse function is a function that cancels out or undoes a function. So what I mean, in terms of an example, if I have this function like f of x, if I apply the inverse, which is denoted by a -1 as a quote-unquote exponent, if I apply the inverse, then that is going to leave me just with an x. So essentially what happens is that the function and its inverse cancel each other out, and leaving you just with the x. Like we've seen this quite a bit before. Some more common examples that you see algebraically would be like plus and minus. So like if you take like plus 5 and then you apply minus 5, those are a function and its inverse that will cancel each other out. Times 3 and then go back and divide by 3, again, inverse functions that cancel each other out. Squaring, or square rooting then, sorry, and then squaring. Again, functions that cancel each other out. So it happens here as well. Now the notation shouldn't scare you. The f just names a function. We don't have to know anything about it, but if we know we have its inverse, we can cancel it if we apply them together. Last confusion about these. Don't let there be confusion about these. I threw these in just so we can talk about them. These are just variables. Okay? They're variables just like x and y. But when you study geometry in a more traditional sense, These are the more common variables you see for angles. What's a T? That's theta, that's phi, that's alpha, that's beta, which is like a B, that's gamma, that's MA, and that's delta, like a D. So these are just the Greek letters that we use to denote variables. Okay, so let's get down to it. So what is trigonometry? How does it work? Why do we care? Well, these are pretty simple questions. So trigonometry is the study of the measurement of triangles, which is a really, really fancy way of saying it's a technique used to solve triangles. Okay, so trigonometry is specifically this technique we use to find a missing length or a missing angle of a triangle, given the right information to start. The official definition is, the official translation, I should say, is to study the measurement of triangles. Well, how does it work? Well, it takes advantage of a property of similarity. So the property of similarity takes advantage of is proportionality. So if I have this angle that I can guarantee to be right, and then I have this other angle that I can show to be the same, we accomplish angle-angle similarity. And because we have angle-angle similarity, we know for a fact that certain ratios have to turn out to be the same. So because we have right angle, reference angle, giving us angle-angle similarity, we know that xy has to be the same as zy. And that is how it works. Like, that is the whole point of how this works. So it doesn't matter how big or how small this triangle gets, okay, as long as we have angle-angle that matches up, we know that xy and let's see, I need to change a variable really fast. I don't know why I repeated that one. It's called W. Okay. Again, it doesn't matter how big or small this triangle gets. We know because of the properties of similarity, mainly proportionality, that xy will always be in the same ratio as zw, as long as we can guarantee angle-angle similarity. So that's how it's based. Like, it works because of angle-angle similarity. Okay? So if we have these two triangles that we know are going to be similar through angle-angle, the ratios are going to be the same. Guys, that's all trigonometry is. That simple observation spawned a whole branch of mathematics. So why do we care? Well, hopefully the why we care is going to be obvious, because this allows us to find missing parts of a triangle. As long as the triangles are right triangles, you have a reference angle. Which, by the way, forms angle-angle similarity. And then you have at least one side length. And so you have something to compare the ratio to. That's really the whole idea. So if you have this right angle reference angle that guarantees angle-angle similarity, so if you have one more side, you should be able to find the other two, because you can use the ratio to your advantage, which you saw over and over and over again. So let's get into the meat of it. So how do you use sine, cosine, and tangent to solve triangles? Well, first of all, don't get freaked out by the name. The sine, cosine, and tangent are just names given by the discoverer to one of the three ratio combinations. So if we have this sine of an angle, and please make note that that is an angle, the reference angle, okay, that just refers to the opposite over hypotenuse ratio. Cosine refers to the adjacent over hypotenuse ratio, and tangent refers to the opposite over adjacent ratio. These are just some three most common ratios that we use. You could invert these, but they would give them different names. Like if you flip sine over, we call it cosecant. If we flip cosine, we call it secant. And if we flip tangent, we call it cotangent. So when you use sine, cosine, and tangent, well, you have to kind of really investigate what this says and understand the pieces. So we use sine, cosine, and tangent when we're giving the reference angle. And we have either one of the side length. So this has to do a lot with the fact that the sine function demands an input of a reference angle. So if we don't have the reference angle, we can't use a sine function. I can give you a quick example of this. So like if I have a triangle that I know is right, and let's say this angle right here is 40 degrees, and I know this side length is 10, that's a perfect setup to use sine, cosine, or tangent. So like if I wanted to find the hypotenuse, let's call it h, I would definitely look at 40, look at the ratio that I have, and realize that I'm dealing with sine. I have something to put into the angle. I have this angle here, 40, so that's going to be my input. And then I use the opposite over hypotenuse ratio. In this case, it's 10 over h. Now from here, I just have to do some algebra to solve for h, but the point being, as long as I have the angle, I should be able to use sine, cosine, and tangent. So that's something maybe you want to highlight, is that you must have reference angle. Okay. How to use sine, cosine, and tangent? Well, I kind of showed you an example up here, but let me maybe do a little more in depth. So I'll use the same exact problem setup. Let's call this one 40. This is 10, and we got to find h. Well, first of all, you have to see any reference angle, look what you got, and that's opposite over hypotenuse. So certainly we can write the sentence sine of 40 is equal to 10 over h. Now we can have a couple choices here. We can go and actually find the decimal value of sine of 40 and then plug it in and then cross multiply or what have you, but I'm going to use a little algebra off the top. In other words, I'm just going to solve for h. I know we can get h out of the bottom of a fraction by multiplying both sides by h, canceling those out, giving us h times sine of 40, and that's going to be equal to 10. I want to get h by itself, so I'll divide by sine of 40. That's not going to freak me out or anything because I know sine of 40 is a ratio and therefore just a number. So I can certainly divide by it since it is just a number. Those will cancel. And so h should be equal to 10 divided by the sine of 40, which if I go to my calculator, knowing of course that we're defaulting to degrees, and if not, I'm going to have a very, very bad day. Okay, so if I take 10 divided by sine of 40, h should be 15.557, which makes a lot of sense because that is hypotenuse, that is the longest side length, and then I do. So again, the steps are going to have to be to pick a reference angle, which of course we do so we can know what to call the parts that I've actually been given. You have to pick sine, cosine, tangent based on what you have, and then you need to write the sentence before you solve. Okay, those are things at least we're looking for when you're solving this. So what happens if you don't have the reference angle? Well, now we have to bring in three new terms: arcsine, arctangent, arccosine. Now, if you're wondering what those are, these just refer to the inverse of those functions. Okay. I don't know if we use those terminologies in every single classroom, but just don't again, let's not freak out. Arcsine, arccosine, arctangent, those are just the archaic way of saying the inverse of those functions. The way you probably see them most often instead of seeing arc sine, you'll actually probably see it written as sine, and then you'll see like this -1 power. That -1 is just a default way of saying it's the inverse of this function, not the actual function. Excuse me, arc cosine is the same as cosine to the -1, and then arc tangent is the same thing as tangent -1. Okay, but usually when you say those out loud, you either say arctangent or inverse tangent. So when do you use sine, cosine, and tangent? Well, you got to understand the function, and then you have arc cosine, and you use the cosine ratio, and then okay. So if you kind of do some thinking here with me, and you investigate these functions, you notice that we've done a switch, which isn't too surprising considering that they were an inverse. But the sine inverse function demands a ratio for an input, and then it kicks out an angle for an output. Well, if it demands a ratio for an input, when we use it becomes pretty obvious. We should use when we need to find an angle. Okay? So in the same way that we're going to use sine, cosine, and tangent, if you want to find side lengths, you have to use arc sine, arc cosine, arc tangent if you're given side lengths and you want to find an angle. So how do you use it? Again, becomes a fairly simple point. So let's say I have this triangle, and I know that this side is 5 and this side is 12, um, and I want to find this angle. Let's call it theta. Well, this is a perfect inverse problem because I have side lengths but not the angle. The thought process is the same. Number one, I have to pick a reference angle. In this case, it's going to be theta. Okay. Number two, I need to decide on a ratio. Okay, so in this particular case, if I'm standing at theta, I have opposite over adjacent. So I'll do this part in red. I'm definitely going to use a tangent inverse ratio because I'm given the tangent numbers. Feed 5 over 12 into it, because that's opposite over adjacent, and should kick out theta, which, by the way, is step 3, which is write the sentence. Okay, so this thing, that's the sentence I'm talking about, like this whole thing. And number 4, solve. So here's where we don't have to, we're going to probably use a calculator exclusively. Like, I'm going to ask you to understand what the tangent function is, but no, all it's doing is taking 5 divided by 12, okay, and then finding the value for it, and then searching like a big trig sheet until it actually finds the angle that hits it. Okay, so 5 divided by 12. Oh, okay, so the angle that I have here is 22.620, rounded off, okay? So not too bad. So I use sine, cosine, and tangent when I have a reference angle, or maybe I should add that. I have a reference angle and I want to find sides. I use the inverse function if I have sides and then I want to pick an angle. Okay, right there. All right, guys. So that's all I have for the notes. That's a basic trig. That's really what the test is going to be over, your ability to do that. So here's what I'm offering. I need you guys to write a conclusion now to complete your notes, but I'll incentivize it. Don't forget that if you to do a conclusion well, you got to highlight 3 words or phrases that make the most sense to answer the essential questions. Use those in actually written conclusion. Probably 2 to 3 sentences seems the most appropriate, but you can go longer if you need to. Post that to Edmodo in the main group page. Let's not put that into any of our small groups. Let's put that in the main group page. And then if you do that, I shall give you test bonus points where the quality of your response corresponds to the number of points you'll get. Okay, so those are your notes. I hope that helped. If not, well, that's okay too. At least you have some notes now to refer to just in case. So as you're prepping for this test in a couple days, here's simply another resource for you, right? You guys have a good day. Thank you for bearing through the announcements, and I'll see you guys later.